Good morning. In the today's session, we'll start learning about the concepts of network layer. Okay. In the last session, we have already completed with the switching techniques. Okay. Now we'll start working with logical addressing. In this logical addressing, we have to concentrate about the two concepts, that is IPv4 and IPv6. Now, first we have to understand about what is meant by this IP. Okay. IP means what? Internet protocol. Okay, this is an IP address which is assigned to a device connected to a network. Whenever if you want to see the IP address, you can simply just press the command in the command prompt, then you can see the IP address. That means how you can go only to know for the communication, you are going to use this IP address. Okay, now it defines the technical format of the packets. Mainly both the networks, that is IP and TCP, are combined together. Okay, and so they are referred to as a transmission control protocol and internet protocol. Okay, it creates a virtual connection between the source and destination. It creates a virtual connection between the source and destination. Okay. Now here, the IP address consisting of two parts. Okay, the first is the first one is the network address and the other one is the host address. Okay, here the IP address consisting of two parts. One is the network address and host address. And there we have the two types of IP address, which I already explained. Okay, now in the today's session, we'll learn about this IPv4. Okay, now here, what is mean by this IPv4? This is a version 4 of Internet Protocol. Okay, this is a version 4 of Internet Protocol. For example, this is a IPv4 example. Okay, that means it is a current version and the most commonly used in IP addresses. Okay, and here we have this 32-bit address written in the 4 numbers. Okay, and each and every number is separated with the one dot. Okay, and this address is unique for each and every device. Okay. Now, here, now in the above example, you just see here. Here, the above example represents the IP address, okay, in which the group of numbers separated with the periods, okay. Now, it is called as an octet. Now, here, now each number is an octet, which is ranges from 0 to 255, okay. And this address is going to provide you a unique address, okay. Now, here, just see in this. But here we may also have some disadvantage, because in the current world, the computers does not understand the IP address in the standard numeric format as the computers understand the numbers. Okay. And the binary number can be 1 or 0, because the computer can understand only the binary digits. Okay. The IPv4 consisting of 4 sets. Each of these sets represents the octet. Okay. Each of these sets represent the octet. Okay, now we have to convert the given IP address into the binary number. Okay, now here we have the given IP address is what? Here they have already given us this 66.94 and 29.13. Okay, 66.94.29.13. Now we'll see how to obtain the binary representation for the given IP address. This is our task, how we are going to obtain the binary address for the given number. Okay, now I have already told you, now we have this 8-bit octet. That means here this is a 2 power 0, 2 power 1, 2 power 2, 2 power 3, and 2 power 4, 2 power 5, 2 power 6, and 2 power 7. Okay, now here just this we got, but here if the based on the number, we have to give either 1 or 0 only we have to give to provide the binary number. Okay, now see here, the first step what we have in the first digit what we have is 66 is our first digit. 66 is our first digit. To make this 66, first we have to convert this 66 number into the binary number. Okay, now what I'm going to do, what is my task to obtain this 66? First, we have to put 1 under the 64 and 2 as the sum of 64 and 62. Here I have already told you how we got this number. Okay. And based on our requirement, you have to keep either 1 or 0. Okay. Now here, 64 plus 2, 66. Now we got. And the remaining bits will be 0. Now what is our requirement? I need the 66. That's why here we kept 1 for the 64 and 1 for the 2. And the remaining all the numbers are 0. Now the binary number for the 66 is 0, 1, 0, 0, 0, 0 and 1, 0. Okay, this is the binary number for the 66. And what is our next number is 94. Now to make the 94, the same we have to do. And we have to make this as a 94, 64 plus 16 plus 8 plus 4 plus 2. Now this is a binary number for the 94. Okay. Now the next number is what we have, 29. Okay. 29. To make the 29, what we have to do here, I get this one for the 16 as well as 8 as well as 4. Okay. Now the binary number for the 629 is 0001101. Okay. Here to obtain this 29, we have to put 16, 8, 4 and 1 as a sum of these numbers. Okay. Is equal to 29. Okay. 16. Here. This also one small mistake here. This also 1 we have to keep. Okay. 16 plus 8 plus 4 plus 1. Now it is 24 plus 4, 28 and 1, 29. Okay. Therefore, the binary bit version of 29 is 0001101. Okay. Now here, the last number is 13. I already know the last number is 13. This is the last number. Okay. Now the last number is what we have here. To obtain 13, we have to keep 1 under the 8, 4 and 1. 8 plus 4 plus 1, I'll get the 13. The remaining bits will be 0. Okay. Therefore, the binary version of this 13 is 0001101. Okay. Now here we have made the binary number for the given IPv4 number. Okay. And what is the disadvantage for this IPv4 here? Currently, the population of the world is 7.6 billion. Every user is having more than one device. Okay. This connected to the internet. The private companies all rely on the internet. As we know that IPv4 produces only 4 billion addresses, not more than that, which are not enough for each device connected to the internet on a planet. Okay. Although the various techniques invented, such as various length mask, network address translation, okay, as well as port address translation, as well as classes, inter-domain translation, okay, all these things has been developed, but to conserve the bandwidth of IPs and slow down the depletion of an IP address. Okay. Now in the next session, we'll learn about the IPv6. Have a nice day. Thank you.